Central tendency. Central tendency, it's a single value. It's usually a single value. And around this single value, all the data of the distribution cluster. So there's your single value. All other values of the data distribution, they cluster around this single value. So this single value in a sense is a representative value that represents all other values of its data distribution. And there are three measures of central tendency that you need to know. Number one, mean. Number two, median. And number three, mode. So for example, let's say we have a data distribution, and the data distribution we have is marks of 9 students. The marks of 9 students come out to be 9, 1, 3, 3, 0, 4, 8, 7, 6. In this data distribution, you have to find number one, mean. Mean is equals to sum of all observed values divided by the number of observation. As you can see in the example, you have been given a total of 9 marks of 9 different students. In order to find the mean of all these marks, all you have to do is sum them up and then divide it by the total number of students. So that way you will get 41 divided by 9. So in a sense, mean is nothing but your statistical average. Mean is your statistical average. Second is median. So median is defined as middle value. So we have our data distribution here, right? We have 9, 1, 3, 3, 0, 4, 8, 7, 6. If we look at this data distribution and try to find the middle value, we'll find this 0 right here. Because before 0 there are 4 values, and after 0 also there are 4 values. So the median is 0. However, this is wrong. The reason it is wrong is because the definition is not complete. Median is not just any middle value. It is the middle value when the data are arranged in either ascending or descending order. So first you need to arrange the given data in either ascending or descending order. Let's say I arrange it in ascending order. So I get 0, 1, 3, 3, 4, 6, 7, 8, 9. After you have arranged the data in ascending order, now you can find the middle value. And the middle value comes out to be 4. Because before 4 there are 4 values. After 4 there are 4 values. So 4 is right in the middle. And this value is the median. So median is equals to 4. Finally, you have your mode. Mode is nothing but simply the most frequent value, or the value that comes most frequently in the observation, or the value that has the highest frequency. That's your mode. And in this data distribution, you can see that the number 3 has occurred 2 times, and all other numbers, they are present only one single time. So the mode is obviously 3. So this was in case when the number of observation is odd. There are altogether 9 marks of 9 different students. Now let's look at the same thing when you have an even number of observation. So let's say we have marks not of 9 students, instead 10 students. So you have 9, 1, 3, 3, 0, 4, 8, 7, 6. Let's add 9. So now you have a total of 10 different students. In order to find the mean, you simply apply the formula, that is sum of all observed values divided by number of observation. You'll get your answer. In order to find mode, you need to find the data that is most frequently found. So there's your 3 that has occurred twice. However, there's also your 9 that has occurred twice. So in this case, you have two different modes and they are 3 and 9. So this kind of distribution is what you call bimodal distribution due to the presence of two modes. Whenever there is presence of more than one mode, you call it polymodal distribution. And the final question is to find median. Let's first arrange this in ascending order. So you'll get 0, 1, 3, 3, 4, 6, 7, 8, 9, 9. In case of odd number of values, you could simply find a middle value before which and after which there were equal number of values. However, in case of even, let me write here, even number of data, even number of values, there are two middle values. So there's your 4 and then 6. Before 4 and 6, there are 4 values, and after 4 and 6 as well, there are 4 values. However, median is a single value. So you can't write 4 and 6 both as your median. You need to find the average of 2. 4 plus 6 divided by 2, which comes out to be 5, and 5 is the median. So again, we had little bit of trick involved in finding median. Under median, if the number of observation is odd, median is simply the middle value. For example, 1, 2, 3, 4, 5, 6, 7. Here, the middle value is the median. But if number of observation is even, then median is your average of two middle values. Two middle values. For example, 1, 2, 3, 4, 5, 6. Here you'll find two middle values, and the average of this is your median. Mathematically, when n is odd, median is equals to n plus 1 by 2th item or value when the values are arranged in ascending order. For example, 1, 2, 3, 4, 5, 6, 7. Here there are a total of 7 values arranged in ascending order. So 7 plus 1 by 2 or 8 by 2 or fourth value. Now you need to find the fourth value. This is the first value, this is the second value, this is the third value, and this right here is the fourth value, and this is the median for the given distribution. When n is even, median equals to. Let me find the formula by using logic. Let's get an even number of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When there are even number of values, there is no one single middle value. You have instead two different middle values. In this case, there are two different middle values, 5 and 6. Before this, there are 4 values. After this also, there are 4 values. 5, 6. 5 is your n by 2th item. N is 10 divided by 2, 5. And what is the fifth item? Sorry. Yeah, n by 2th item. So 10 by 2, 10 is the total number of items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divided by 2 comes out to be 5. The fifth item is 5. Similarly, this right here is one item after the fifth item or the sixth item. 5 plus 1, sixth items. Or in other words, you can write it n by 2 plus 1th item. Now, obviously, I said that median needs to be a single value. For that, you need to find the average of these two. So the median comes out to be n by 2th plus n by 2 plus 1th divided by 2 value in ascending order. Now that we have seen the three various measures of central tendency, we need to know the preference of these central tendency. That is, which central tendency is more preferred for calculating whenever a data distribution is given to you. First, what you need to know is that overall mean is preferred over median and median is preferred over mode. So mean is the most preferred central tendency and mode is the least preferred central tendency. The more reasons behind that you will come to know when I tell you the merits and demerits of each of these central tendencies. However, you also need to know the best measure of central tendency as per the data type that is present in the data distribution. Overall, it's mean better than median better than mode. However, this preference varies as per the data that is given. There are three types of data that we have already learned: nominal, ordinal, and metric. Nominal and ordinal, they contain qualitative variable. Metric contains quantitative variable. Nominal contains names. For example, blood groups. Let's say you find out the blood groups of 100 people. Now, you can't measure mean of blood groups. You can't measure median of blood groups. But what you can find is the blood group that is the majority among them, or which blood group is most seen. And that is what we call mode. So mode is the preferred central tendency for nominal data. Second, ordinal data. In ordinal data, you have qualitative variables arranged in an order. For example, severity of cancer, you have first stage, second stage, third stage, fourth stage. Here, these are your variables that have been arranged in an order of severity. Similarly, severity of accident, less severe, moderately severe, severe, highly severe. Again, there is an order of variables. During calculation of which central tendency do you need an order? You need an order of the data during the calculation of median. So for ordinal data, the best central tendency is median. Finally, metric data contains quantitative variables, all the numbers and stuff. And the best central tendency for numbers is mean. However, there is one extra thing that you need to know. What is skewed metric data? In skewed metric data, you have quantitative values. However, the quantitative values, they are skewed. This means there is tiltation, or the values are tilted on one side. That is, there is presence of outlier. For example, let's say we have weights of 5 different students and they are 60 kg, 62 kg, 54 kg, 56 kg, 60 kg, and 61 kg. Here, the values of weights given are quite comparable, or they are normal, shall I say. As per the height, you have weights. In this particular scenario, you have metric data, and the central tendency that you can find best applicable is mean. However, let's say the scenario has been changed. You have 60 kg, 62 kg, 54 kg, 56 kg, 60 kg, and all of a sudden you find a student with weight 121 kg. This 121 kg value is very extreme as compared to other values. It is excessively high. This weight right here is the outlier in the given data. And if you calculate mean in this particular condition, the mean will be highly shifted towards the extremes or towards the outlier. So the mean will not be the best central tendency to calculate. It is not appropriate to calculate. Then the second appropriate one is median. And median is the best in this case as well. The reason being, median does not change when the extremities change. That is, it does not matter how high the extremities are, how high the outlier is, or how low the outlier is. I mean to say, let's say we have some data 1 and then 60, 61, 62, 64, and then all of a sudden 120. Here we have two outliers, 120, which is extremely high as compared to your normal data, and then 1, which is extremely low. There are two outliers. In this case, if you calculate mean, it will be highly tilted on one side. But median, on the other hand, it is not affected because median is the middle value. Here, the middle value is the mean of these two numbers. It does not matter what the numerical value here or here is. So, mean is the best central tendency which can be measured for skewed metric data. Okay, after that, so you have a relationship between the measures of central tendency. There are three measures that I taught you: um, mean, median, and mode. Let's say enough data has not been provided. All you have been given is either mode and median, or mode and mean, or median and mean. In that case, when two of them have been given, to find the remaining one, you can directly apply this formula, which shows the relationship between all three of the central tendencies. Mode equals to 3 times median minus 2 times mean. This, by the way, formula is valid for bimodal distribution, where there are two modes that are present for the data distribution.